Hello, today we are going to talk about alkanoic acids, or you can call them carboxylic acids. Now, carboxylic acids are a group of organic compounds that have got at least a carboxylate group. Now, the simplest alkanoic acid is called methanoic acid. Now, this group here, one carbon, two oxygen atom, and hydrogen, is what we call the carboxylate group. Or, in other words, it is the functional group. When a reaction takes place, when a alkanoic acid is involved in a chemical reaction, this is where actually the action, remember a chemical reaction, we have some action. This is where the action takes place. Now, the simplest carboxylic acid is methanoic acid. As you can see, it has got only one carbon atom, and one carbon atom, we say it is a meth. Now, because all the hydrogen, the carbons are joined by a single bond, we say that now it's the methanoic acid, like that. So, because of one carbon atom, now this is the open structure, this is the condensed structure. This is an open structure whereby you see how the bonds are in this acid here. Now, if we increase the number of carbon atoms, so we have two here now. We are increasing the number of carbon atoms, and of course, the number of hydrogen atoms now will increase, such that now we have two. So you see we have increased the number of carbon atoms. The same now will happen to this one. We shall have, we add now the carbon atoms. We add a CH3 like that. So now we have 2 carbon atoms, and this is the open structure, this is the condensed structure. Now, because the number of carbon atoms is increased, it becomes an F. F means 2. So this molecule here is an ethanoic acid. As you see, we still have the carboxylate group. We say that every carboxylic or alkanoic acid must have this group here. So this is an ethanoic acid. Eth means 2 carbons. Now, if we increase the number of carbon atoms again, so we are naming like this. Now we have 3 carbon atoms, like that. Then for this one, we increase, we put a CH2 there, this CH2, this group here, and this CH3 there. Now this one now becomes a prop. Prop meaning 3 carbon atoms. And this molecule here becomes a propanoic acid. As you can see, the functional group remains the same. Now, the importance of this functional group remaining the same is that all alkanoic acid will be involved in some chemical reactions, and these reactions will tend to follow the same path. They will all react the same, because this is where the reaction usually takes place. Now, if we increase again the number of carbon atoms, like that, so we also increase here. We have 1, 2, 3, 4. Those are 4 carbon atoms. So the name of this molecule now becomes a butanoic. But means 4. So this is a butanoic acid, like that. And this will continue if we increase to 5. Now, like that. The name of this carboxylic acid becomes a pentanoic acid. Now, if you increase to 6, it becomes hexanoic acid. To 7, it becomes heptanoic acid. 7 carbon atoms becomes heptanoic acid, and so on and so forth. So that is simply how we name these organic molecules. We call carboxylic or alkanoic acid. And as we have seen, the common feature is that all of these molecules have got this functional or carboxyl group. We shall see the importance of this group in our subsequent videos on alkanoic acid. And that's the end of this video, whereby we have seen the naming of alkanoic acids. We meet in the next video. Thank you.